So in this video we're going to look at how the oxidation reactions are actually carried out in the lab. So I've got this rather complex looking apparatus here. I'll just talk you through what each bit is. So the first thing to point out is this: we've got this round bottomed flask here, and you can see that it's bright orange. So we've got the acidified potassium dichromate inside that flask. That's our oxidizing agent, and we've also got an alcohol in there. This piece of apparatus here is what we call a condenser. Essentially it's two glass tubes in one. We've got a central glass tube running right through the middle of the apparatus, and wrapped round that is a second glass tube which is going to allow a flow of cold water. It's going to come in at the bottom here and it's going to flow up and out at the top. Now this will surround the inner glass tube, and you'll see the purpose of that once we get the experiment underway. So this is called a condenser. I'm just going to turn the tap on now and you can watch it fill up. So watch it at this part here. Just slowly turn the tap on. You can see there's the water, and now we have a flow of water, steady flow of water through the outer glass tube. So obviously to make this reaction take place we need a source of heat. So I've connected a very small Bunsen burner, a micro burner, and I'm going to position that underneath the flask, and we're going to heat up the contents of the flask and watch what happens. So you can see we've got the classic colour change there from orange to green. So an oxidation reaction has taken place inside this flask. So we're going to explain now what the purpose is of the condenser in a vertical position. Now the condenser in the vertical position is known as the reflux position, and we can control the product that we get from this reaction by positioning the condenser in either reflux position, which is what we've got set up at the moment, or the other position that I'll show you after this is called distill or distillation position. So to have a look at what's going on inside this flask, the reaction's obviously taken place. Now inside this flask I had a primary alcohol. So we know from a previous video that primary alcohols are oxidized twice. They are first oxidized to aldehydes, and then the aldehyde is further oxidized to a carboxylic acid. So what's been happening in this flask is the aldehyde's been produced. Now the aldehyde's a very volatile liquid, very low boiling point, and it evaporates very easily, and obviously the only route it's got is to travel up through the condenser. And because the condenser is constantly surrounded by cold water, remember the cold water comes in at the bottom, out through the top. If you watch closely, sort of roughly here, hopefully you'll be able to see drops of liquid running back down into this flask. So what's happening is, as the aldehyde's produced, it evaporates, but because this cold water is cooling it back down into a liquid, it condenses and falls back into the flask, where there was more oxidizing agent, and so the second oxidation takes place. So by using the reflux position, we generate the second oxidation product, the carboxylic acid. The definition of reflux is the continuous evaporation and condensation of a volatile substance without loss of any product. So you can see there the top of the condenser is open, and that's because none of the vapour can escape, because it condenses before it gets anywhere near the top.